Hello, I have my first example. My first example will not involve the memory commands. We're going to be using add, or, and, sub, and add immediate. But there's one thing that we have to add, and that is that R0 is always 0. Maybe we would say defined as equal 0. So we remember that no matter what we do, R0, register 0, is going to contain 0, and that will help us. All right, let's go over the C statement that we're going to need to do. Now basically, we have some initialization, and this initialization happens with the compiler. Then we do stuff with the variables that we've declared. So now that we have the variables laid out, what the compiler/assembler would need to do is associate a register with X, Y, and Z. Now the compiler, or assembler, gets to do that. However, in a problem that I may give you, I'm going to have to define what registers are associated with what variables. So this is a given. R3, register 3, is going to be associated with X. Register 5 is going to be associated with Y. And register 19 is going to be associated with Z. Now I've told you before that we have a general purpose register machine. So I'm just deciding these things. And we have that caveat that register 0 always contains 0. So we really have a 31 register general purpose register architecture. So I've decided on these, I've given these to you. All right. So first we say that we have to instantiate a variable X, but we're not assigning it a value. So register 3 does not necessarily have to have any initial value. But variable Y, or register 5, has to first be initialized with 7. And variable Z, register 19, has to be initialized with 12. All right. Then after we get done with the initialization, what we're going to do is we're going to do some arithmetic. I had some trouble in class with the logical operations, so we're only doing arithmetic. However, we don't have to do the arithmetic. All we have to do is write the assembly language instructions in order to mimic what the compiler would need to do. So, let's get started. In the initialization phase, what we're going to do, now remember, X is uninitialized, so we don't care. We know it's associated with register 3, but we don't have to put anything in it. So we're going to use that characteristic of register 0 in order to use the command add immediate as if it were a load. Now add immediate always has to have 2 registers and then an immediate. So we want to initialize Y, which is register 5. Then we want to load an immediate directly into it. So we're going to use register 0. Now we have the constant 7 that we want to put into it. So we put 7 into the register. The add immediate takes 0, the contents of register 0, adds the constant 7, then puts it in register 5, which is associated with Y. I'm going to do a similar thing with Z. So Z has to be initialized to 12, but Z is associated with register 19. So we do cache 19, cache 0. Now when we're writing assembly code, we use the cache symbol, but when we think about registers, we use the R. So add immediate into 19, which is Z, the value 0, and then the constant 12 that we want. Okay? And there's no semicolons or anything as we write this. We just have a line break. All right, that's the initialization. So that corresponds to the divided line, the dotted line here. Now we're going to do the bidness. The bidness here are the 4 arithmetic statements that we have in our C code. So we have x equals y minus 751. We do not have a subtract immediate instruction, but we do have an add immediate instruction. Note that the constant that we have as an immediate can be negative. So for this instruction, x equals y minus 751, we can use the add immediate function. Add immediate, where do we want it to go? Into register 3, which is associated with x. So we do cache 3. Then, do we want to put 0 here? No. We want to use y as the first argument. Y is associated with register 5. So, into R3, which is x, we add y, which is register 5. Now, you might be confused because there's a subtraction sign, but what we do is we put in the immediate negative 751, and that's how we use an add immediate as a subtraction. Next, we have y. Y is going to be z times 4. We don't have a multiply instruction. So, what are we going to do here? Well, we're probably going to resort to cracking each other's skulls open and feasting on the goo inside. However, another option, since ultimately y is going to be clobbered, we can do this. First, we load y with z times 2. We do that by using the add command, the add instruction. So, the result, y, is going to be clobbered anyway, so we're going to use register 5. Then, we're going to put the register z, R19, twice into here. So, into the register associated with y, we're going to add 19 and 19, which is z times 2. Okay? Then, heavens, we need times 4. What we'll do is we'll then do an add into 5, 5, 5. Now this is not the 555 timer, which is the best-selling integrated circuit of all time and can produce square waves, both positive 50 duty cycle and negative 50 duty cycle, asynchronous, you name it. It's not the 555 timer, it's add 5, 5, 5. And what this does is that register 5 then receives z times 4. Okay, we have finished with the second C arithmetic operation. Next, z was used here, but now z is going to get clobbered. So we have z equals x plus y. So we do an add. Where do we want it to go? Into z. Z is associated with R19. What are the arguments? Well, we always have 3 arguments. We always have 2 arguments and 1 destination. Here, we want to take x and y associated with 3 and 5. So we take 3 and 5, we add it, we store it in R19, which is associated with z. Next, we have the statement y equals 0. There are 3 different ways to do this. Let's do one way. Add. We want y to receive 0, so the destination is going to be 5. We can do add 5, 0, 0. We're done. We've completed our task. However, I'm going to put in parentheses another thing that we could do. We could have used add immediate destination 5, source 0, which is 0, register 0, and then the constant 0. And as an exercise for the reader, I'm going to let you think about what is the third way we could do that, and that might involve the sub instruction. Thank you for watching. I'll see you next time on Examples in 424.